Today I want to discuss the problem of conversion from one system of calculation to the another. And let's consider the case of conversion from the decimal system of calculation to the binary one. And let's imagine that we have the value, or the number 147. It's a random number that I have now imagined, and that's what let's start this process. There are different ways, but the most useful and is the division and finding much more some residues that can represent this binary representation of this number. Oh, let's start. This method is based on the division I have mentioned previously, but it's sum. It's some stair method. It's like I'll build some stair, you'll see it, but it's not a stair where, for example, somebody climbs from as a human with hands in a metric style, absolutely green, from down upwards. It's another type of stair. Maybe it's a stone stair, but well, let's stop discussing it and let's start. Okay, and we will divide this number on 2. And let's find the most near number to this one. I mean, the difference between the number that will be written here and this one mentioned number should be found from this equation. You can cry now, or it's not a cry, you'll think this, why we use a so difficult method, it's not very interesting. But if you want to program this idea, it's the most suitable for you. And sometimes it's enough common method, and if you have very difficult and very long number, and you don't have any ability to achieve the computer, for example, you're playing lecture, you must answer this question immediately, or some other cases. You shall use this method. And I mean that you must find the integer y, and this difference should be 0 or 1. And if this number can be divided on 2 without any residue, then the difference will be equal to 0. But if we have the number that can't be divided without residue, we have 1. And this means that let's continue this activity. And the most near to this one number that can give 0 or 1 and should be integer can be found from the further condition. For example, y is equal to 146 divided by 2. Okay, is the most near number. And if you'll see it, 147 minus 146 is 1. And let's write it here. The residue is 1. Is the lowest all of this binary representation of this number. And let's find by the division what does it mean. What's y is equals 73. Okay, and let's write it here. Then we repeat this process, but now we have found the most neighbor number, where the difference between this one number 73 and some y multiplied 2 should be equal to 0 or 1. And let's write it. 72, 1, and 36 should be multiplied on 2 for realizing of 72. And let's continue this process, and you see that we have built some stair. The next step is the division of 36 on 2, and writing here 36, 0, and let's find the number that can be realized from the division of 36 on 2 is 18. And so let's repeat this process. 18, 0, and so on. 2, 8, 1. The next step gives us the following realization. It's 4, 4, 2, 2, 4, 0, 2. And now let's divide it on 2. 1, 2, 0. And let's continue this process until we'll gain 1. And let's write it here. This will be the final stage. We can divide unity on 2 and residue and gain some integer y. That's why this process will be finished on this time. And let's write our being representation of this number base 10, base 10, and the representation of decimal number. And we will say from the reverse order, it will be the opposite parameters, then 0, 0, 1, and so on. And let's rewrite it again. 147 base 2 equals 1, 0, 0, 1, 0, 0 unit, 1, 0, 0, 1, 0, 1, and 1. Alright, and the bin representation will be given in the following form. Okay, in this form we have realized. Thanks for your attention.